So to add FreeRTOS, we come to Manage Runtime Environment. We come to RTOS, and over here we have the option to either select FreeRTOS or Micron. We select FreeRTOS, and we just add the basic files. For this example, we need the core, we need a config file, we need timer, and then we need a heap. So when we click here, everything is set. And over here, if yours says YAMSys RTOS, you just click to select FreeRTOS. Over here should be FreeRTOS, config FreeRTOS. I'll teach you how to use YAMSys RTOS in future sections, but we use the core FreeRTOS for this first lesson. Once that is done, we click OK, and then we rebuild our project to make sure everything is up and running. And as you can see, everything is working the same way, 0 errors. So to add the header files of FreeRTOS, all we need to do is right-click, include header files, right-click, and then insert include file, and then we come over here, and then we want to add the FreeRTOS.h. And in this particular project, we'll be using tasks, so we have to add the task.h as well. I click over here, I add it like this, and yeah, and it's included. And as you can see, if you observe here, under our project tree, there is a new one here known as RTOS, and this one here encapsulates all the files from FreeRTOS, which we shall spend quite a lot of time taking a look at. So once this is done, now we're going to create 2 tasks and then blink the blue LED in one and then blink the red LED in one, and this will be our very first real-time application for this very exciting course. So let's proceed. So to create a task in FreeRTOS, we need to use the XTaskCreate API. We use this API to create the number of tasks we want. Then we use the vtask start scheduler to start the scheduler. So let's start by creating a task. We create a first task. We create over here, and over here everything is done outside the while one loop. In fact, when we're done, the while one loop will be empty because the code would not reach here. As soon as the scheduler is started, this whole area becomes unreachable. So we create a task by invoking XTaskCreate like this. This function accepts 6 arguments. The first argument is the task function, which is the code that would be executing as the task. Each task requires a task function, and a task function is just a function running in an infinite loop, as we shall see. And the second argument is a symbolic name we can give to the task. So I'm going to create a task function here. I'm going to call this blue task controller. I'll just say, let's give it a more descriptive name, blue LED controller task, like this. So that's the task function. So we have the red marks here because we've not created a function yet. So when we create it, it will disappear, and we can give it a descriptive name like blue LED controller, like this. So the first argument, the task function, the second argument, the name of the task, and the third argument is the stack size of the task. We give it a size of 100, and over here the unit is in 32-bit. So 100 over here means allocating 32-bit times 100 for the stack. And remember, 32-bit is known as a word, so you hear that in FreeRTOS the stack is word sized. So I have 100 words here, and a word means 4 bytes in effect. So 4 bytes times 100 here, that's what we have as our stack amount. So we have 400 bytes of stack essentially if you compute. So yeah, moving on. So the fourth argument is a parameter we can pass to our task function. So we would explore how to use this parameter later, but we're not using it for this particular lesson. So I'm just going to put null over here like this. And then after this, the next argument is the priority. So in FreeRTOS, we can assign a number of priority to our task. And the higher the number, the more important the task is. Unlike other real-time kernels, in FreeRTOS, priority number 1 is lower than number 5. Number 5 has a higher priority essentially. So I put a 1 here, and yeah, and actually we can set the highest number of priority we want in our FreeRTOS config.h file which we shall explore later. So once we've set the priority, the last argument is a handle we can give to this task that we're creating. But we shall explore how to use the handle later. Since this is just a getting started project, we can just assign a null here. Null means we don't need this. So then we have this created. We've got this task created. It's called blue controller task. And then this is the description. This is just for debugging purposes. This is the stack size. This one here, we're not passing any parameter to this task. Priority number 1, we don't want to create a task handle for it. So what we have to do is we can come down here and create our task function that we said we would create. Blue LED controller task. It's a void with argument. Actually, it's not void. It takes a void pointer to a void. So star PV parameters. So this is the way of writing task functions in FreeRTOS, like this. Like I said, it's just a normal function with an infinite loop. While 1, just like this. So there's a blue LED controller task. So to make this reachable, we just have to put the prototype up here because we declared it down there. If I put this prototype, and you'd see the red line disappear. Right. So we've created our first task. And we're going to create another task, and this is going to be the red LED controller. And what I'm going to do is I'm just going to copy this instruction here, and then put it here, and change the words to suit red. I'll just change this to red, and change this to red as well. And I'll leave everything else. So I'm giving them the same priority, so they're going to run in a sort of time sharing way. And because we've not created this, we've got here. We've got that there, so I'll just make a copy of this, and this is the task function for the red task, and I'll change the word blue over here to red, like this, and put a prototype up there by taking this, putting it up here, like this. Great. So now all we have to do is take the content of our main function and put in our task functions. So I'm just going to copy this here, and I'll bring it here actually, yeah, then I'll delete it. I could have cut it actually, but we want to toggle just the red LED, so I'm just going to clean all the other LEDs and keep just the word red in here, like this. And I'm going to do the same for this. I'm going to copy, and then, oh, this is for blue. We have to change that to blue. This is blue task, BLUE. And of course, our local variable that we created here for the delay, we just have to cut this, and then I'll paste this here like this, and then I'll paste it here as well. We're using it here too. And we are set, everything is done. All we need to do now is to start a scheduler. So like I said, the while one is empty. So to start a scheduler, all we need to do is invoke vtask start scheduler, like this. And now we just rebuild our project by clicking over here. And once it's done, we download onto our board. And as you can see, just the red and blue LEDs are blinking, and they are blinking in the real-time kernel. The real-time kernel is what is controlling them. So this is the getting started project, and we shall explore much more fascinating, much more advanced part of this very popular real-time kernel, FreeRTOS. And that's all there is for this lesson, and I shall see you in the next lesson.